Hello and welcome everyone to this tutorial video on our exercise submission system. Today we will be talking in more detail about the exercises, their submission, and how you guys can get feedback about the models that you submit. So just a short recap of what we talked about last week. This is the exercise schedule. As we said, we have in total 11 exercises, of which only 8 are submittable. So these are the 8 exercises you will be submitting online to our system. And if you pass 7 out of these 8, you will be eligible for the bonus. The first exercise you will be submitting is exercise 3. It's very important that these exercises have a fixed deadline. Usually this deadline will be Wednesday afternoon, but you can see the exact deadline on the submission system's website. Each exercise has an info tab with details on the deadlines. So as we said, every submission is graded and you're given a score. In order to have passed the submission, you have to get a score that is greater than this threshold score, which you will get by email and you can also see on the website. So first thing that you have to do is install Python on your system. Officially, we require a Linux distribution to work on, but this is not really necessary. Many students have successfully done everything on Windows. I will actually be showing a live demo on Windows, but everything is easier and tested on Linux. So we will provide you with this file, this README file, where you have instructions on how to install all the environment and the stuff we need. Basically, for those of you who know, you just use you can use Anaconda and install an environment with Python 3.7. And we have this requirements.txt file where all the packages you need are listed, and you can just install everything with one command. For new Python users or those who don't know what we're talking about, if you follow the README file, it should be fine. If you do run into issues, don't hesitate to contact our tutors, either in the office hours or just post a question on Piazza. I'm sure many students will benefit if you make it a public question. So how to submit the exercises. You will first have to register on our submission webpage, which we link right here. So this is what the first page looks like when you try to log in. Here, for the first time, you will have to enter your matriculation number, and you click register, and then you get an email to your TUM email address, which states your username and password that you can use here to then log into the system. What's important is that some of the students who are not properly enrolled at TUM at this moment, or we have some students from LMU or PhD students or students from other faculties at TUM, all these are external students. When you try to register here, this will not work for you because we retrieve the matriculation number from a database which contains all the students who are registered to the course through TUM Online. Since this will not work for you, we have this Google form over here that you guys should fill out, and we will manually create users for you. Probably you will get just dummy matriculation numbers from us that you can then use here for the registration. If you run into issues with the registration, just again ask on Piazza. Once you've entered the submission system, you will see the submission for exercises here. So this is what an exercise submission looks like. You can see here the description of the exercise, the start date, the deadline, and the required grade in order to pass. It's quite simple. You choose a file, you upload it, and it gets evaluated. What's important is that you always upload a zip file. Do not upload 7-zip or RAW or any other kind of compressed format folder, because only zip will work. And the entire folder with all the code is submitted, not just the model. So once you have submitted, you can refresh the website of the submission system and you will see the status of your submission. For each exercise, you will have this log here of all your submissions, and you can see their statuses. So you can see when you submitted it, what happened with the submission, whether it has passed. Passed means it's above the score, and you're also able to download the files in case you want to see, you want to revert your code, or you want to see what you submitted. So that's possible as well. So just some examples here what the status could be. So these are submissions that were finished. That means it was uploaded successfully, it was queued, it ran, and it returned a score. So as you see here, score 99 passed, score 60 passed. This submission, which got a score of 50, was finished but did not pass, so it's yellow. You see here this submission number 16 that's queued. It still hasn't been run on the server. You can cancel the job. If you think you have a better model to upload, or you might have an error in this code, you can just cancel it and save the resources and time. Number 20 here is a submission that encountered an error. You will be very likely to encounter such submissions if your code has a runtime error. This is what will happen, and you will get a somewhat informative email to your inbox that says what the error that was encountered, and that would help you debug your code and fix it. So this leads us to some questions you might have. You don't want to code in notebooks. Can you use your favorite IDE? So the answer is yes. We don't really care which text editor or code editor you use to write your code or run it, as long as everything works. So as long as it's submittable to the system and it runs and you get a score, that's fine. What's important is that you don't change the structure of the code. We don't expect you to write everything in a single function. You can add helper functions and so on, but do not change the general structure of the code. Do not touch the base classes. Otherwise, you will just break the whole pipeline. And we'll just mention that anything that you code will be uploaded. So you upload the entire folder with the code, not only the trained models. So how do you know you passed the exercises? Once you submit a model and the score that you achieve is higher than the threshold, then it appears both on the submission system, as you see here, but you will also, of course, get a notification by email to your TOOM email address, where it tells you your score and whether you have passed this exercise or not. You will get this message as many times as you submit models. So for every model that you submit, you will get an email telling you what happened to it. Did it pass? Did it encounter an error? Or did it not pass the threshold? You can keep submitting models even after you passed. So you can submit a model that doesn't pass the exercise's threshold, but if you previously have passed it, then the highest one is what counts. So you don't have to resubmit the good model. And in general, there is no real limit on how often or how many models you can submit. You might find yourself submitting quite a few models until you hit the accuracy score that you need to pass. Don't worry about that. But also, on the other hand, please don't try to DDoS our submission system. So just use it in a normal way and do not write scripts that try to submit many models, because that will just overload the system and your fellow colleagues will not be able to submit their models and evaluate them on time. Couple of warnings. So cheating and plagiarism first thing, all your code is uploaded and logged. So if we have a suspicion that two people are using the same code or the same models, then we have access to all the code. And do not try to hack the submission system or the evaluation pipeline. Last semester, there were 2 students who tried to do that it didn't end too well for them. This shouldn't be an issue, but just don't do this, because in the end you won't be able to access the exercises or take the exam. Only submit the necessary files, not the data sets. So you will be uploading zip files with all the code and the models for this exercise, but we don't want the data sets there in these zips, because then it will just be unnecessarily heavy. If you do use the script from the code that creates the zip, then that shouldn't be an issue. One other thing is that the submission system has limited resources, and if currently we have 900 something students enrolled, and if 400, 500 students all try in the same time, that is an hour or two before the submission deadline, to evaluate many models and debug them, then it might happen that the queuing for the evaluation will get kind of long. And you just don't want to find yourself in this situation that there's 1 hour left for the deadline and evaluating your model takes 20 minutes because there are so many students who are doing it at the moment. So just plan ahead and avoid this. Another important notice is about copyright. So all the lecture material, including the exercises, as well as the videos and the slides, it's all copyrighted, and we reserve all rights to it, and we ask you to not distribute it and do not share your solutions. So some of you use GitHub to upload their code to and manage versions. You can upload it to GitHub, but do not make that repository public. Now we will show you a live demo of exercise 1, and you'll see how we can use our submission system. So in order to start working on an exercise, I first have to activate my environment. So I chose Conda, so I will activate the environment I created, which is called I2DL. So I do Conda activate I2DL. It's now activated, and I'm already located in the folder, so I can do the command Jupyter Notebook, and it will open a browser with Jupyter Notebook already enabled and open in this location. So as you can see, this corresponds to the content of this folder here, and you see exactly the same things. And if you go into exercise 1, you see the 2 notebooks we have here. The notebooks are the main entry point for each exercise, and here in this folder, exercise code, this is where you may have to code in some of the files. So if I open this one, so here's the first notebook. And for those of you who don't know how Jupyter Notebooks work, this is a very nice and interactive way to use Python. You have these cells here where you're able to write pieces of Python code, and then you just execute these cells one by one. For example, here we have x equals 5, print, you just do Shift Enter, and it prints it, and then you can keep using the cells and do stuff with x, so the memory is shared between cells, and you can just keep doing, for example, print x plus y, okay, y is not defined, and you just get the error, same error Python would give you. For example, we said y, and you can basically just keep going and just read through the notebook and execute and follow the demo. So here, for example, we can see which Python I'm using. So if you have a version that's less than 3.7, it should return an error. I'm using 3.8.5. That should be okay. And as any Python code, you can import all the packages that Python has to offer, and it's executed. And here we have a little introduction to NumPy. Those of you who know NumPy, obviously this would be redundant for you. But basically NumPy is a Python package that allows you to use matrices and tensors and do linear algebra quite efficiently on the CPU. And here's a little introduction. So here we have a matrix that has 1, 2, 3, and 4, 5, 6, so a 2x3 matrix. And this is how you define it. And you can print the data type of the matrix and the shape. So the data type is in 32, and you can see the shape is a tuple. It's 2x3, so it has 2 rows and 3 columns. When you access elements in a NumPy array, then you can use slicing. So for example, you can set B to be all the rows of A and only the first 2 columns of A. So that should return us all the rows. So that's these 2 and these 2 columns. And indeed, B is a 2x2 matrix and only has 1, 2, and 4, and 5. It goes on. I will not cover all of these. You can do these on your own. And similarly, as you would do in Python, you can load images. Here we do it with matplotlib, and we show them. Also, a feature of these notebooks, you have these inline questions. It's really important that you don't ignore these questions when you solve the exercises. Sometimes there might be important questions here. It already happened once that an inline question from the exercise was the exam, so you should pay attention to these. Of course, your answer here is not graded, but if we do ask something here, it means you should stop and think about it. So external files. Not all the exercise code or the code you will be writing is in these cells in the notebook. So from the notebook, we will be accessing code from outside the notebook. So as you see here, from exercise code networks dummy import dummy, and you initialize this dummy class. So if we actually go and look at the exercise code, which is here, we have exercise code, networks, and we have this dummy.py where the class dummy is defined. So you can either edit the code here on this web interface, or you can, of course, always just open the folder and open the code from here and just use your favorite code editor, for example, Sublime, and edit the code this way, or with your IDE. That doesn't matter. Just hit save, and then once you change something here, then it should change when you run it from the notebook. So as an example, in this exercise 1, the task here is to change this dummy machine such that it returns a score. So currently, if we import this dummy model, so I do Shift Enter to initiate it, and then I run the test, and then it returns a score of 6. So the goal of this exercise is to get a score that's 60 or above. So what you have to do is go to the file here and change the score that it returns. So whenever you have to write code in these exercises, you will see this block of code. It will always look like this with a to-do, and it tells you what you have to do here. And this is where you write the code between these two. So here what we have to do is just set x to any integer larger than 59 to get passed. So for example, I will set it to 66. and I will hit save. And now if I rerun this function, Shift Enter, it returns 66 and dummy test passed. So now that my model is good enough, all I do is save it. So we have this function save model. Next thing, when you save the model, you might encounter a pickling error. So that's an error that occurs while it tries to save the model. And sometimes the way to solve it is just restarting the kernel of this notebook. So if you don't get this error when you save, everything's good. Next thing is to create the zip file that we will upload to the submission system. And for this, it's also automated. And all you have to do is use this submit exercise function with the name of the exercise. So I do this, and you see zipping successful. Zip is stored under here. And if I open this location, then we see here that in exercise 1, we see the zip file that we will need for the submission. So in order to submit this model, we have to go to the submission system. So the submission system is located in this link. And what you have to do is log in. So as I explained earlier, you will have to first register with your matriculation number. If you put in a wrong matriculation number, then you will get errors. Either you put in a bad number, or you're an external student who is not registered on TUM Online, and then you have to fill this form. If you've already gotten your user, then you just use what you got in your email to log in. And this is what the submission system looks like live. So you will go to submission. And right now, exercise 1 is what we're submitting. So we choose the file, and we will upload the zip file that was created here through the notebook. I upload this file, click upload. So you get here feedback that it was uploaded and will be queued and evaluated. You should receive an email when it's finished. And what you can do is just hit refresh. And you can see this was indeed finished. And I got a score of 66, so I have passed this exercise. And that is all you have to do for submitting the model. What you also have here is this bonus and leaderboard, where you can see your score and how it compares to others. So you see others put in higher scores, so you can see them here and their user. One more remark I'd like to make is that we also have a second notebook for this exercise. It's called Colab Introduction. If you open it, you will see this is a soft introduction to Google Colab. It's a service from Google that allows you to run basically notebooks. It's called Colab Notebooks, but it's very similar to Jupyter Notebooks. And our notebooks should work pretty seamlessly on Google Colab. And the advantage there is that you get free access to GPUs. So right now it's not relevant, but later down the line, where you will be training heavier models or many models, then you might want to use the GPU. So this shows you how you can use Colab and mount files, and you can play around with it. But of course, it's not necessary for exercise 1. As a general comment, exercise 1, of course, is not mandatory, but it is highly recommended that you do it now and you do it this week, because what typically happens if you wait for next week when the real exercise is on, then only at that point you figure out that your user for the submission system doesn't work, or you don't know how to use it properly, or you have problems with your Python environment, and then you just waste valuable time that you should use for solving the exercise and not for solving these kind of issues. So I highly recommend to start as soon as possible with setting up your environment. So that will be all for the live demo, and we'll go back to the presentation now. Now, to summarize, today we had this video which walks you through exercise 1 and our submission systems, as well as the notebooks. And we're also uploading today another video with tutorial session 2, which is the math recap. This will be done by Franziska, who was a tutor last semester and did this math recap pretty well, so we're just going to reuse this one and we ask you to watch it. You will need all the content there to solve the exercise sheet that we're publishing this week, which is exercise 2. It's due next week, so Wednesday evening or Thursday morning until we publish the solutions to it. On Monday, you should be watching Lecture 3, which is Introduction to Neural Networks and Computational Graphs. And then next Thursday, we have Tutorial Session 3, where we'll talk about dataset and data loaders. And that is all. So see you guys next week, and thank you for tuning in.